So looking at the satellite compute, we can think of it in this particular terms. So we have our satellite unit. You can think of it as a satellite that is orbiting there, that is having dedicated communication modem, which is usually maintained by the particular satellite operator. And this modem is, of course, responsible for being able to receive external communication, but can also have an onboard computer that is used to forward the traffic to a particular payload. And you as a user of a particular satellite are usually focusing on how can you integrate your particular payload on the satellite itself. And as of now, usually one payload is equal to one particular user in the system. Which, of course, as you can think about, doesn't necessarily scale because you would like to find the means on how can you scale the particular access to the payload and provide the capabilities to other users. And this is the part where we try to provide the solution for space, is to ensure that we can have a multi-tenant compute payload where the individual parties that are running on the same physical payload do not necessarily have to trust each other. And the current challenge we see that why companies are not willing to necessarily share the access to the same resource is because of the sensitivity of the respective workloads they are running, and also do not feel comfortable of providing the access to their particular compute because there is a clear demand on the part of scaling, but at the same time there is a lot of trust issue with respect to providing the access to other parties as well. And this is the part where Space Fabric tries to come into picture and in general solve it. For the simplicity, we currently focus on a single payload on a single satellite, but you can think about it as well as a part of the right share options. There can be actually multiple payloads on the same larger bus system as well. And since we are talking about space, we also have to understand a bit of the unique constraints, which means that there is usually a bit more challenging way on how do we disseminate heat. You also have to work with the power budget. It's no longer easily possible to just go and add additional solar panels once you are deploying your satellite. So you have to actually fit and navigate in particular constraints of the overall system as well. But at the same time, even though there is a lot of challenges, we see also a lot of interesting opportunities, which is one of them, the obvious one is like once the satellite is in space, it's very hard to have a physical access to it, which makes it quite attractive from the security perspective as well. Depending from where you actually launch your satellite and from where you operate it, you actually can kind of consider some aspect of the legal neutrality as well. And something that we have also seen in the recent events as well is that the aspect of satellites which are orbiting around the globe all the time, you don't necessarily care about borders as we know nowadays. And as long as you have the right equipment to be able to communicate with your satellite, you can actually also bypass the terrestrial exposure and can have a communication with your particular infrastructure as you want as well, which is quite unique with respect to also the modeling of the respective threats as well. As a part of the fundamental solution of Space Fabric, we are relying on the technology of trusted execution environments. I believe this is something I don't have to dive into detail, but the general idea is to provide you a secure location for your data and code where you can execute it for the data in use. And in general, depending on the particular TE, they can provide confidentiality and integrity protection and also provide you attestation capability so that way not only you, but also the others that are interacting with your particular system can get a confidence that the attestation that they are relying on can be something that you can verify and get a confidence that that particular software or other aspect of the respective software stack are the genuine software that you want to interact with as well. These also come with certain type of challenges, which is something that is actually serving us as an inspiration of what we can do and how can we design for trusted execution environments and overall architecture of the future. And overall, we see that the physical security is a big challenge as a part of the TEs. Okay, I'm comfortable with, for example, trusting the hyperscaler of your choice to provide me the security regarding the TEs itself. You still have certain aspects of the root of trust assumptions as a part of the manufacturer being part of the flow, which is currently being actively worked on, but still is something to definitely consider. And still a persistent issue that of course is with current systems becoming more prominent is the supply chain issues. Meaning that not all of the aspect of the software stack that you are actually using and trusting as a part of the TE, trusted compute base, is currently publicly verifiable, it's closed source, and there is no easy way to actually attest and verify all of these components are actually genuine and do not, for example, have inherited bugs in them. And something that is applicable to all TEs, that TEs in general focus on solving the problem of what is the code you are running, but they don't necessarily provide you any guarantees of where is this code executed itself. There is already an ongoing work regarding providing you the guarantees on Earth systems to make the assumptions regarding the threat model explicit in the direction of proof of cloud. So this is something that I'm also happy to talk with you, but in general we see that this is a common pattern for TEs on Earth as well. So these type of challenges are motivating Space Fabric, and we try to go and try to mitigate several of them as well along the way. So this is the part of the focus of the talk where we want to provide the steps on how do we actually plan to mitigate the key challenges I outlined and unlock new type of use cases for a space-based industry as well. And this is the overall holistic view of Space Fabric that tries to address many of these challenges, and I'll be happy to provide details in the upcoming minutes of my session as well. And the main two components that are enabling this is a novel protocol called Satellite Execution Assurance Protocol, which will be binding the execution to space, and also will be providing additional details about the whole implementation flow of Space Fabric as well, and how do we actually bring the design that I'll be covering today to reality in the upcoming space mission as well.